All right, for people who are joining this live stream, this is a brainstorming effort to try and think about ideas for digital contact tracing. And it sort of came out of me thinking about this a bit yesterday and realizing that there's a interesting algorithmic problem that we might have something to contribute to. So to set the stage for everyone, somebody is asking, what is digital contact tracing? So the idea is if we're going to stop all being locked down and isolated to prevent the virus from spreading, the best thing to do seems to be to let people go about their business. But if anybody tests positive for the virus, to be able to trace everybody that they were in contact with, so that the cell of people that were infected by the virus can be isolated and quarantined so that it doesn't spread to the rest of the population. And we can see very clearly from network models that if one could do that, it makes a big difference, and it probably allows things to be opened up. So the question here is that the main way of doing digital contact tracing is through phones, and there are really two basic ideas that sort of have been floated. One is keep GPS tracks for people and see who's overlapped who. That has all kinds of privacy issues. It also isn't very realistic because GPS doesn't work well inside, and it doesn't. It's not that precise, and so on. So a much better scheme seems to be to have apps running on phones that can exchange proximity information through Bluetooth. There are some attempts to make protocols which I think are only partial for to safeguard privacy while knowing essentially who encountered who. So the data you have is this phone encountered this phone. I had made a Bluetooth connection to this phone at this timestamp. And that is only kind of revealed to anybody if the owner of one of those phones tests positive, and then that causes some chain of notifications to happen to other people who were in contact according to the according to this phone thing. Let's see. It's so it's interesting. Someone on the live stream is commenting that CCC, I don't actually know who that is, published a list of requirements for contact tracing systems today. Conveniently. Okay, here we go. This is let's find out. That's a. Oh. Okay. This is from the Chaos Computer Club, which I didn't think was necessarily. Okay, this has to do mostly with privacy issues, which is an important issue. But let's talk about some of the other issues first. So the primary. Okay, so the thing that seems to be technically possible is to get information on when two phones came within Bluetooth range of each other. The problem with that is it only gives you instantaneous contacts, and there seems to be lots of evidence that the virus can hang around either as an aerosol in the air or can hang around on surfaces. And so it is also of interest to know kind of delayed encounters. That is, somebody was in that place 5 minutes after somebody else was in that place, or somebody potentially touched some object that somebody else touched. And so I think, and maybe there's a much more official version of this because I just was trying to figure this out for myself, and I don't, I've been paying some attention to this literature, but I may not have it correctly. I was sort of identifying two forms of delayed infection. One is object mediated, and another would be location mediated. So object mediated means person A touched an object and infected it and handed it to person B. And in the extreme case of kind of a relay race, person one infects the baton and it gets handed to a sequence of other people. That's kind of a moving object type thing. You can imagine the same issue with fast food or with uh, um, various deliveries and things like that. Second case is somebody is in a place and they infect something that is statically in that place, including the air, and then that's picked up by other people. So the question, the first algorithmic question that I was interested in is, given only simultaneous contact information, given only instantaneous encounter information, to what extent can you infer these other kinds of location-mediated and object-mediated kinds of transmission? So that I think becomes kind of a graph theory problem that one has to solve there. But maybe we should. So that's sort of one bucket of things. Is can we solve the problem of deducing from instantaneous? So this is an example here, very simple example. From instantaneous encounters, can we know that sort of this person might have infected this region of space, basically? But we don't know the space from GPS information. All we know is that that person was in the same place as this person and so on. We are essentially trying to reconstruct the space from the intersection of what in physics might be called world lines. So we're trying to, reconstruct essentially a space-time from an intersection of world lines. And that just happens to be a problem that we've been interested in for physics reasons, completely independent of this effort. So anyway, one thing is to talk about that. Another is to talk about the various kinds of BLE, Bluetooth Low Energy approaches, and what can actually be done with Bluetooth devices. Another is to talk about privacy. And I think one important piece to that is I would have the suspicion that if this is really going to be implemented, it has to be done using some kind of public mechanism, whether it's blockchain or otherwise, that in which there can be many vendors of apps that share only the information share only information sort of in some public database, rather than having to have everybody have the same app, for example. I don't know if people have comments on that. Philip, you were saying something about Bluetooth, not just phone-to-phone Bluetooth, but also phone to device and to car and so on. Is there a thought about how that might work? Because don't you have to have an app? I mean, in order to have the Bluetooth, transaction, don't you have to have an app running on both phones or both devices?
Well, certainly you can see the other BLE devices in your vicinity. I mean, if I just bring up my BLE app on my phone here,
yeah, right.
I see that there's a bunch of other phones around, and there's an iBeacon, which is a little bit mysterious. I don't even know what that is or where it is.
Right. Yeah, I also have one of these BLE things. Right. So an app can get the BLE environment, and potentially that app could get. So what good would that do one? So let's imagine that. Oh, I see. That would give one not only these two phones were nearby, but if they hashed their BLE environment in some way, you could tell that. In other words, you could tell that a person had been in the same BLE environment. Actually, that's a pretty good idea, right? I mean, so in other words, if each person were to send some kind of version hash of their BLE environment, you would be able to determine that another person was in the same BLE environment. Is that kind of the idea? I mean, of course.
Yeah, I mean, I don't think I would try and hash the whole environment. Effectively, it also, I think, would partially solve the problem of not everybody running the app, because if two people, A and C, both see another device within some time span, then you can deduce that they were fairly close to each other, although they didn't quite run into each other. Maybe that missing device, the B device, maybe it's a stationary device, like I'm going to say like a car, but cars are pretty stationary these days. Or it might be another phone walking around, but they're not running the app.
Right.
Well, you might also be able to tell somehow whether it's. I mean, because there are some right? I mean, you presumably want to make some distinction between, for example, phones and iBeacons, which probably don't move around very much.
I don't know whether you know the information. I mean, I think the BLE, I can bring up my BLE app, but I think it just tells you the device name and, you know, the dB level of the Bluetooth, doesn't it? I mean,
well,
I don't.
Sure, right. I mean, I don't think there's a field that's like mobile queue, right? But you can tell from the device name, for instance, almost certainly whether it's a phone or whether it's an iBeacon or something. I mean, a bunch of the, maybe 5% of the time you can't tell what it is, but that's okay.
Right.
The device names aren't unique, are they?
The device names aren't, but there are unique identifiers.
And you can get those with BLE?
Yes, and I believe the unique identifiers are also they have a manufacturer prefix.
Well, I've got mine. I've got my ID up here. So there's long UUID like IDs. There is a name field and there's a RSSI, which I guess is the signal, is some kind of signal data. And what is there's a timestamp on the signal. Oh, that's just when the BLE scanner saw that thing. But so, for example, here I have no idea what these are, but this is fascinating. I mean, I'm really out in the middle of nowhere. Why on earth do I have any of these things visible? Okay. But there's a name here which has like HTCBS and then some ID number, which presumably is I didn't think I I know what that is. I have a Vive. Yeah, that's what it is. I have a Vive near VR system nearby. That's what that must be. How weird. But okay, so there's a name field, but the name field is blank for most of the Bluetooth devices at least that my scanner sees. But so okay, so what would I mean, that's another piece of information in this kind of encounter thing. I mean, you would probably be able to deduce if a particular device, yeah, you don't. I mean, is there any way of deducing from this graph effectively that a device is stationary, for instance?
Well, if two people who have the app both see the device at different points in time with similar GPS coordinates,
we don't know their GPS coordinates.
Why couldn't the app record that?
Okay, I see. Actually, that's a good point. The app on device could record the GPS coordinates.
Right, and if enough people pass the same object and it's in roughly the same place, we can.
Yeah, but we can't exchange that information unless we have a protocol for doing that privately.
Fair enough.
Well, we can a single device can deduce if another device is stationary by measuring if the signal strength varies proportional to the GPS distance. So as the device is moving in physical space, if the signal strength varies accordingly.
Well, wait a minute. I mean, so okay, what sensors do we have? Okay, so sensors that we have, potentially, we have the accelerometer, right? Which can tell us whether the phone is moving. We have the BLE environment, and we have basically GPS. Are there any other sensors that are relevant?
Well, one thing to note, by the way, is the fact that the GPS. So, at least I don't know about on Android, but I know on iOS that when you're using GPS in the background, the accuracy is slightly restricted. So you don't have super accurate position information. And also, of course, if you're indoors or if you're like in a store, like a grocery store or something, it's probably also not going to be as accurate. So I don't think you can rely necessarily on like the super accuracy of the GPS.
Right, but the accelerometer can definitely tell you. I mean, I one of the issues is things like people on trains, right? It's clearly just saying, are you in the same physical coordinates is not adequate. I mean, you can still touch an infected thing that's on a train co-moving with you, so to speak.
I think there's an additional complication there, because you could imagine a horde of people, so to speak, walking through a train station, and they are in motion, and then they all get on a plane, and then they are relatively stationary relative to each other, but they're on the train that's moving. But looking at just the signal strength BLE environment, it hasn't changed between the absolute in motion state and the relative stationary state.
Yes, but okay, but so but let's take yeah, I mean, there are other sensors here, like, for example, cameras and so on, but camera, microphone, those kinds of things. But I don't think, none of those can be switched on in the background, and people aren't going to want those on, basically. So these are the, oh yeah, there's also Wi-Fi. I don't know, what information can one get? I mean, there's tons of information that people claim is accessible from, let's see.
Network name.
Well, you get the network name, right? But you get the Wi-Fi environment like the BLE environment. I mean, that's basically the other thing that you get. And the Wi-Fi environment, well, I would assume that's more stationary than the BLE environment.
That's true. I mean, the Wi-Fi environment, you can more or less, well, you can kind of guarantee that'll be more stationary than the BLE one, because the BLE one you can't really guarantee much is stationary.
Right. Okay. So the question here is, okay, so let's just remember what we're trying to achieve here. What we're trying to achieve is a person was at a person who later turns out to, be infected, was at a particular place, warn other people who were at that place within a certain amount of time thereafter. That's the basic objective. And oh, by the way, I mean, there are other things that can be done. Right. I mean, there are clearly things that can be done which involve deploying other sensors, deploying other things, e.g., QR codes on train cars and stuff like that. QR codes, beacons, etc. But I think the first question is, can one do it without requiring any change of the environment? So I mean, so the objective is. Okay, so now the question is, I mean, let's just review for a second the encounter-based, the phone-to-phone encounter-based protocol for privately transmitting information on who was near who. So there's an example of that in, let me see if I can pull it up. One of the projects that is doing let's see. Oh gosh, where is this? Check out white paper. Okay, I think this is an example of a protocol, which maybe we can just look at here. There's a couple of aspects of this protocol that trouble me, actually. So the idea is, and there are a couple of ways that it seems obvious to extend this protocol. So every few minutes, phone generates a UUID, right? Then every phone keeps a log of every UUID they've seen, right? But I don't understand. I think that then okay. So if one of the phones ends up being, we can call it an infected phone, then that phone gives the list of UUIDs that it has received and that it has sent to some public database that then calls people. But I don't understand how the public database knows how to call people. This is, I guess, a question.
Well, I assume it sends some sort of push notification, and then each app that receives the push notification compares the list of IDs in the message with the list of IDs that it has stored locally that it has seen.
So in other words, you're saying that the idea would be the app, the provider, the central provider, sends push notification to everybody with the app containing information on the ID that was the infected ID, and that every app locally compares that infected ID with its list of stored IDs.
That's what I would expect, yes.
It doesn't have to be a push. It's just if you want to know whether you encountered someone infected, you could just query the database.
Well, at some regular interval, which is at some level the same as a push notification, just with latency.
Right, but so the idea then is that the only the only thing that would be revealed to the central database is the list of IDs recorded by the phone that was effectively the infected phone.
Yeah.
And okay, so one of the issues with that, obviously, is it doesn't. So one thing you could do to deal with the problem of non-simultaneous contact is if you inform the and maybe there's a problem with this protocol, but if you inform,
if you contaminate the location, and
what's
then
that?
somebody else, if you contaminate the location, like touch a doorknob, and then somebody else comes at the same place, but that's not no.
No, I understand, but so the whole point here is to figure out how to get. Okay, so you've got the simultaneous contact phones, right? And then in one of these graphs, we're dealing with other phones that encountered the same phones, which is a proxy for determining that they were in the same place. But the idea would then have to be that after you have your phone, if you're the infected phone, you get a bunch of IDs, and those IDs will get push notification. But then you have to go another level, which is those IDs then would have to re-push to and they would have to relay it. They would have to push again, looking at their list of IDs.
Yeah,
that makes sense?
You lose a level of verifiability by doing that, because in that specification they describe this permission number, which is the idea is basically that the authorities, whoever they are, give the person who's gotten a positive test, they're infected, some number they can input to the app that basically gives them the ability, the authority to send out this push notification, because you don't want false alarms going off or people messing around or whatever. But I don't see any way to transfer that that authority onto people who receive the notification and then see then want to send out their list, or the app wants to send out their list.
Why don't they have to go through a permission? Why don't they get some kind of token from the first person? I mean, in other words, the person, the original, the central authority is given a token to the initial person, right? Then the initial person, then a subsequent person is again known because they uploaded all those UUIDs to the authority. So the authority knows, so that the authority can distribute more tokens to the second level UUID holders.
Yes, but how do you verify that list of tokens, that list of UUIDs that the second level person has uploaded is authentic? In the case of the first level person, because presumably the authorities have verified that the person has a positive virus test, while that there isn't going to be a positive virus test in the second level case, or at least not necessarily.
I don't understand, but how do they spoof something? Because they've got to have their list of UUIDs has to be corrupted in some way. Or I mean,
well, yeah, this would be something. This would be them intentionally trying to send out a notification where none is warranted,
where they just have a bunch of random UUI. But how would they be able to do that? Because they wouldn't have a token. They couldn't send out notification unless they have a token. They won't get a token unless they got a token because they were on the UUID list of the original infected phone.
But the initial push notification isn't sent out to just the people who have that UUID. It's sent out to everybody, because the server does not know who has what UUID, or what set of UUIDs, UUID history. So it necessarily has to be sent out to everybody, and then locally that the list that's been sent out is compared with the list that each
I see what you're saying. I see what you're saying. You're saying that the initial infected phone could have spoofed UUIDs on it. You don't know that. The only thing.
No, I'm not saying that. I'm saying that the initial infected phone has to send out its notification to everybody in the network, regardless of their UUID. And then each I'd say person, I mean, this happens automatically, but each device then compares the list in the message that it's received with the list that it has locally. And only if they intersect, does it notify the user and then go on to potentially send out a second level notification. But you can't send out the tokens to only the people who are in the list of of potentially infected UUIDs because you don't know who those people are. You have to send it out to everybody and then do the comparison locally.
Yeah, I understand that. I understand that. Okay, so wait a minute. So there's a protocol issue in propagating. I mean, so the first question is, if we had the graph, if we had all relevant encounters, if we knew all of the encounters, can we deduce? Can we do this delayed tracing? That's first question. Because if we can't do that, there's no point in trying to get all the encounters. But if we can do delayed tracing, which I think we can, if we get more encounters, then it is of interest to figure out a privacy-preserving protocol to get more encounters. Now, how does it, in all of these things, we might be able to make lives a lot simpler by picking up some of this other information, like the BLE environment information. So the various comments on our live stream here. Let's see, without a token of authoritatively infected phone, you can't push. Yeah, right, absolutely. Right, so somebody's asking here, why do you want to propagate multiple levels? The reason is because we want to have the possibility to reconstruct this graph to be able to do delayed tracing as well as simultaneous tracing. And yes, that means everybody's app would be getting notifications and they would have to respond to those notifications, but I don't think that's problematic. If no human is in that loop, I don't think that's problematic.
Right. I mean, you could even also schedule them so that, every hour or, every evening or something like that, the notifications go out.
Right. And an individual could set within their app, I only want to be personally notified if I'm within N degrees of an infected person.
Right. Well, that's a different issue. So I mean, let me just yeah, I mean, so there are questions here about how could this work if not everybody was running the app. I think that also relates to this whole BLE environment question. So let's look at the BLE environment question, okay? So one thing that I think is a problem is I don't think you can hash the BLE environment because I think it's too fickle of things coming and going. So, two people for totally random reasons, because one of the BLE transmitters was behind a potted plant that had, done this. They're not going to see that BLE transmitter, whereas somebody else will see it. So they won't compare. So the question would be,
would a perceptual hash work?
Which means what? You mean
a hash where the edit distance, so to speak, between two hashes is
I see. Well, I mean, the other possibility is you simply hash if you've got a list of BLE devices, and isn't there a way of doing this? I'm not thinking of this with a bit field in some way, where basically you're saying, this is my list of hashed things. Am I confusing myself? I mean, you understand what I'm saying? Because the question is, each one of these BLE devices has a UUID, right? So it is the case that there is a unique identification of every BLE device. I mean, and by the way, that allows people, even if somebody isn't running, assuming that they have Bluetooth turned on, even if somebody isn't running the app, there is a good chance that their phone will still show up to other people's phones through its Bluetooth ID. Is that true, or is that not? If you
believe that's true.
Philip, do you have a comment on that? Do you know that is that do people?
If you have Bluetooth turned on, of course.
If you have Bluetooth turned on, yeah. But what I don't know is whether Apple has a constant MAC address for the BLE device, or whether it does the privacy preserving stuff of rotating it fairly constantly, like they do with Wi-Fi Macs.
I see. So what you're saying is that in my BLE scanner, those UUIDs might not be constant.
But the app should be able to obtain its own device's current UUID somehow. Yeah,
but I mean, if the question is, does that other, do two people see that same third phone? What Philip is saying is that third phone might have rotated its UUID.
Right, sure.
And so you wouldn't actually be able to tell it's the same thing. But so my question is, what could one do? Assume that we have, and I mean, from an app point of view, it is easy to access the BLE environment, right? It's just a simple system call in the app. Is that correct?
Yes.
So assume you can access it. What does that? I mean, that gives us, with some probability, if we've got, I mean, with your like perceptual hashing idea, we can tell were those two people in the same place. Because, so in other words, let's imagine that the to be infected phone is recording its BLE environments. Every few seconds, it's just storing its BLE environment. And then the question would be, if could it then for other people, I mean, then it requires no handshake between phones. I mean, so a different approach to the whole thing would be just store the BLE environment, and if that phone shows up infected, disgorge the whole sequence of BLE environments and let other people compare with those and see, based on timestamp and based on environment, were they in the same place or were they in that place, some limited time afterwards. What's wrong with that picture?
I think the problem is there that once you disclose all of that data, then that probably allows me, the attacker, to figure out exactly where you were.
Right. It would have to be the hashes, not the actual raw environments that get disclosed, assuming this hash idea is feasible.
Well, but even if you hash it, I don't think that helps you, because if I know that, okay, for example, if I personally know that, well, I was in this place at noon today and these were the UUIDs I saw, and that's the same as the UUIDs that you say you saw at, whatever other time yesterday, then I know where you were at that time. And so the point is, if I have lots of data like this, I can basically know where everyone is.
Right, and there's no way to put salt into the whole thing to prevent that?
Well, you have to have the salt at both sides, and then you lose the advantage, I think.
Right, but is there some way, what about with some asymmetric encryption thing? Is there some way to have because what you need to know, or some zero knowledge thing, because what you need to know is one person, you need to know, was I, here's this list of BLE things, which has been disgorged to me, so to speak. Is there any way through like a zero knowledge protocol or some such other thing to be able to query, do I match any of these these locations without ever knowing what the locations were?
It's basically a set intersection problem where you don't want to actually discover, you want to discover whether these two sets intersect, but you don't want to discover what the intersecting members are.
Well, I think that's where perceptual hashing would come into play, because you just sort both of the sets, and then take the perceptual hash of each, and then you can then have some value between 0 and 1. I think that or between 0 and something that describes in some manner how close those two values are to each other.
So are there cryptographically secure perceptual hashes?
I don't think they're cryptographically secure.
Which means that you can then, I don't know well enough. I mean, perceptual hashing has been a holy grail for a long time, and I don't know how well that actually works.
I know it's used in image comparison stuff for stuff like image searching.
Okay, so
it's just dimensionality reduction, right? In something that looks like a hash number, but
what do you mean? So you think it just dimension reduces and then hashes the dimension reduced thing?
No, I don't think it's a hash. It is a dimensional reduction that, I should reread about it, but I think it's like for images, it's just dimensional reduction, but with the vector being the right size to do very efficient comparison. It's mostly for efficiency. And then you can, find the nearest image in a huge database, because every hash is encoded in I don't know how many bits, and then you can really quickly search the nearest. I don't think it's not cryptographical at all, I believe.
I see.
So it's saying perceptual hashing is kind of saying as let's do dimension reduction on the data. I think it's about the same.
Fair enough. Okay, so
but
wait a
I
minute.
think it's absolutely true that it's not cryptographically secure, but I think there are two elements of cryptographic security to a hash. One is collision incidents, but the other is being able to reconstruct the original data from the hash.
Sure.
There would be lots of collision incidents here, but I think it's still probably virtually impossible to reconstruct the original data from a hash, which is what we really care about in this case.
Right.
I'm not sure about that either. I mean, yeah, some lost information for sure.
But let's
yeah.
zoom out for a second. Given if we knew, so do we agree that if we could successfully have a protocol that would work through the, BLE environment tracing, that would be a good thing? I mean, is that going to be useful if one could figure that out? Because that would tell one, the real question is, have I been at the, with an appropriate time delay in the same BLE environment as this infected phone, basically, which seems like a useful thing to know. And in a sense, it's a generalization of the question, was I sort of in, if there's a phone-to-phone Bluetooth transaction, then this is kind of a generalization of that, because this also allows the kind of ambient environment to be involved in that. But maybe we should look for a minute at the question of, if all we had was phone-to-phone contact information. By the way, people are asking about, enforcement and so on. I mean, who knows what's going to happen here? But I can imagine a situation that different kinds of places, who knows what, a shopping mall or who knows what it is, would say, if you're going to come here, then you need to be running this app. I mean, I could imagine some level of sort of specific enforcement that would allow, at least for particular locations, that to happen.
There's also an inherent incentive, because by running this, you then get the perk that you will be notified if you were in contact with someone who's infected.
Yeah,
which
right.
is something that's desirable, I think.
Right.
I mean, they might actually switch over how their Wi-Fi works in those public locations to kind of both incentivize it and force people to use it at the same time.
What do you mean? You mean just the public Wi-Fi, but that's not going to be enough to force the phones to do something?
Not the public Wi-Fi. I mean, the public Wi-Fi from like a shopping mall. But you just have it within an application. But you have to either have the application to authenticate on the Wi-Fi network or something like that.
Right. Well, it's relevant for people who want to use the Wi-Fi, but it's not necessarily relevant for people who are just, shopping, so to speak. But that's an interesting point too. That is one leverage point, is the public Wi-Fi networks, yeah.
But by the way, can I say one thing about the zero knowledge proof idea?
Yes.
So I think it would only work if you extended it so that it was effectively a 3-party interactive proof system. Because if you just have a 2-party interactive proof system, then for the same reasons that Christopher kind of gave, the prover could work out where the verifier was, right? Because the prover determines that the verifier also knows the location. So even though they never share what location it was, the prover can still figure it out. But if you had a 3-party system where you had 2 provers, where one prover knows the location, but the second prover knows nothing, and the first prover just sends the challenges to the second prover, who then relays the challenges to the verifier, then
oh boy, okay.
Then the first prover can determine that they were in the same location, but none of the parties are able to work out where the other was.
Yeah, I understand. So one of them is just a determiner of sameness.
Yes. So basically, the challenges are issued and are issued and verified by different people, and as long as that happens, then I think you're okay.
Do such protocols exist?
I've seen 3-party variants of them for things like the Alibaba cave problem and stuff. I'm not sure if any actually exist in practice, but I've certainly read theoretical CS papers about it.
Okay. Okay. Let's maybe turn to a question which I think is, I mean, let's just see whether it's tractable. Okay, so the question is, if you are given encounter information, do you have you can tell two people were at the same place at the same time. Can you tell anything about two people were at the same place, separated by some period of time? So the reason you might think you could tell that is that, there's a crowd of people milling around and somebody,
Yeah.
do you get what I'm saying?
Yeah, you can follow the cluster. I think that's really a clustering problem. Is you find a cluster of many people at the same place, and then in time you can follow this cluster and infer that two persons were at the same place, even though they were not at the same time.
Yes.
But that's, of course, that's required to have the cluster that stay there. If everybody leave the place,
I think
a Starbucks and then it's empty, and then new people come, then you lost the cluster. So
right, and I mean, there's worse cases, like everybody is waiting for a train, and then they, if the train arrives, they get on the train. Let's look. Okay, so there was a thing just worked on last night, and Jonathan made a better version of it here. So the idea, let's try to understand this idea. So this idea had to do with, this is, okay, so first of all, there is a time, this is the pure who was at the same place at the same time network, okay? But what we actually want is who was at the same place at a later time. We want kind of forward light cones in this space, not just, maybe Jonathan, do you want to explain what your code here does?
Right. So, okay, we're just generating some random graph, and then the second line is associating each each undirected edge with a sequence of timestamps. So these are supposed to be kind of all the various times where two nodes were in the same place. And so then the question is,
wait a minute. What is this original graph? The original graph is all of the encounters that occurred. Is that right?
Right. And then we're asking, so then each edge is associated with a list of times for when those encounters might have occurred.
Right. So just to understand the graph that this encounter graph, there is, each node is a person or a phone or whatever else. Each edge really is it should be a multi-edge that represents the different encounters that occurred between those two entities,
which are probably consecutive, right?
Maybe. Yeah, I mean, they probably were hanging around, browsing the same section of the bookstore or something together. Okay. All right. So we've got that.
Right.
Now,
so then the question is, as you say, given a bunch of intersection information about world lines, can we reconstruct the graph of possible causal connections? And so that's what the rest of the code is doing. So it's evolving, it's evolving what in relativity we would think of as a simultaneity surface. And so it's determining, okay, so we're assuming node 1 is infected at time 0.
Yes.
And then the question is, so given that information, who else could have been affected and at what time?
By affected, you mean that they had an encounter. Wait a second, because I mean the most, one thing is the passing of the baton theory, so to speak, where person 1 infects a baton that's passed to person 2, that's passed to person 3, and so on.
Uh-huh.
Right? That will be one form of infection.
Right.
Although I think that is that is one thing worth tracing, but I think that is going to be less important than the was in the same place and breathed in, some aerosolized virus that somebody else breathed out, so to speak.
Right. Right. But the point is that this is sufficiently general that these nodes don't have to just be people. They could also be locations or objects. And the same idea works.
Okay. So this is then a propagation. This is simply propagating essentially the forward light cone of that node. Is that right? Exactly.
So it's like evolving a graph Laplacian, but it's constrained so that it always follows the partial order that is the causal relations.
Okay, so this particular one only had one iteration because it only got to there, right?
Right. So that the matches bit is just determining what's it actually connected to, And then, so now if we jump forward to time 5, it's determining which nodes lie in the forward light cone with respect to that, and then showing.
Okay.
This.
Well, so let's try and look at this. So what is this doing? This
So
is saying
that's just running that iteration, but in a more automated way.
So this is showing. I mean, this is basically like a contagion network. I mean, what is the difference between this and a standard contagion network?
The standard contagion network doesn't have a causal partial ordering.
I see. So,
so you can have adjacent nodes here, where you could have an uninfected node adjacent to an infected node that never gets infected.
Right, because in other words, the reason for that is that person 1 encountered person 2, and then I see.
Or either of them was infected, basically.
Yes, right.
Right, exactly.
Right, but the thing we're still trying to work out is how do we use these instantaneous intersections as a way to deduce not the pass the baton sort of object-based, infection mediation, but instead the location one. I mean, similar to what Etienne was saying about clusters, what is the way to get sort of a proxy for that purely from the network structure? And that was what I was trying to understand. Of can one figure out? I mean, at a simple-minded level, assume you have people randomly flowing around. Can you deduce? Assume, for example, in the random walkers case, assume, in a crowd, for example, people, well, theoretically, they follow pretty decent Maxwell-Boltzmann distribution sort of, gas molecule type behavior, although I can't believe that's really correct when they all decide that they're going to head for the train at the same time and so on. But assume that assume you had some model of the crowd behavior, so to speak. What can you then say if you know that the two point, the simultaneous phone-to-phone contact information? What can you deduce about sort of the spatial structure from that? And I'm sure you can deduce things. I'm just not clear exactly how you can do it.
I have two thoughts on this, which are a little bit different. Like one is maybe you can solve an easier problem of actually having the locations themselves effectively have phones by using things like added sensors, Internet of Things, local Wi-Fi networks, etc.
Yeah,
That's
we
one
were talking
idea.
about that. Yes.
The second idea is you can try to figure out what the infected locations are from this analysis itself, just by where the actual infected people pop up, right? If there's a cluster of the infected people had these contacts, wherever those people are, that's the cluster that you think the area is infected, right? The fact that they share infection later
that's right.
is used to deduce infected area overlap.
Yeah, but look, the point here is, I mean, the potential here is a pretty automated, notification mechanism that works purely at the level of phones, or phones are the only active element. The only thing that anybody is actually doing here is installing apps on their phones. I think that, in a first approximation, that seems like a realistically doable matter of a few weeks type thing, whereas something that involves any infrastructure change is not realistically doable, except conceivably these sort of pivot points like, public Wi-Fi network or something.
Right. The backward idea is that the same kind of causal network tracing you're doing in the forward direction to see this person infected this person, if you run it backward, you can say these people were infected. There had to be a place or person that infected them. And if you don't find in the previous things that have already recorded in the app someone who infected them, you still have backward tracing contacts that tell you someone in their past had to be the infection source.
Yeah, fair enough. I mean, in other words, there's no spontaneous generation of virus, so to speak. It has to come from somewhere. And
if you trace past light cones, their intersection has to contain the culprit.
Exactly.
Yes. Right. Well, that's interesting. But okay. But let's And by the way, I mean,
why don't you just store like a BLE picture of the phone every, I don't know, every few minutes or whatever, and store it somewhere, and then you can go back there.
Store what?
Have like a picture of the BLE of which devices you have around you, and you just store all the pictures one by one in a blockchain or whatever, each 10 seconds or whatever, 10 minutes or whatever you want, and then go back to that.
What do you mean by go back to it? I mean, in other words, I mean, we're talking about storing I'm not getting that. I mean, that was one of the earlier questions here: is can we store the BLE environment? Can we store it in a way that preserves?
I think the idea is that the BLE environment is a proxy for location that could be source of infection. So it becomes an actor in the graph, in the causal graph, right? That this shared BLE environment is a proxy for a location in space that could possibly be a possible source of infection.
Oh, I see what you're saying. But I mean, we already talked about the idea that an infected phone, once it is determined, once it's determined its user is infected, then it has this whole stored sequence of BLE environments. Okay, great. So then the question is, what does it do with that? Because what it's really got to do is it's got to inform people who had an overlap with those BLE environments that they might be at risk.
Right, but the automatic system can do more than that. It can trace back those BLE environments to places where intersection lines converge or are shared as likely sources where actual infection happened. So the other BLE environments that don't have density of those possible infection lines are low probability sources for his infection, whereas the place where it's shared with lots of other people who later became infected is high probability of an infected source.
I see. So wait a minute. You're saying there's a population study that can be done where you're looking at not just, okay, so that's another interesting idea, is if I mean, the hope in this whole business is that the infection levels will go down to the point where there's not a big population to study it for. But in the case where, and I suspect as a practical matter, that sort of the whole isolation policy won't be removed until one is at the point where one thinks that's what's going to happen. But okay, so you're saying, assume there were a decent number of, a significant number of infections, then
right, like take the South Korea case where a whole bunch of people showed up and infected in one church. They traced it back to the church, and then they contacted everybody in the church, right?
Right. So you're saying, okay, so there's a separate thing which is essentially sort of past light cone studies, which is can you go back from that to deduce where, can you determine for a given infection where it came from? We've got a whole bunch of comments on our live stream here that look like some interesting things. Let's take a look at those, and then we'll go forward again.
So these computations sound just like reachability computations, both forward and backward reachability.
In the graph of phone-to-phone connections, you're saying?
Yeah.
I think that's correct, yes.
Even though you call them light cones and stuff.
Right. Sorry, too many physicists here. Yes, it is, AKA reachability.
Right. But it's reachability with respect to direct edges that are given by the partial order.
Right, because it matters that the thing, you can't infect something in the past, so to speak. You can only infect the future.
Right.
Speaking of which, you're determining properties of the space. Is that some form of graph communities problem, where as you're determining whether the edges inside the community sort of minimize the time delay, or minimize the minimum time delay between their intersections, if you see what I mean?
Yes, it is a clustering problem to infer. If we don't store GPS and Wi-Fi environment for privacy reason, if you only have the interaction within the phone, then determining a location for me is equivalent to doing a clustering.
You see, what bothers me about that statement is that suggests that you have to have a static cluster, where I have this.
Well, it's not static in the sense that people are moving out of the cluster and in of the cluster. So you have to see the graph is always changing, right? And but you can still, you can still follow one cluster.
Yeah, I understand.
Time.
My feeling would be whatever you can do with an intermediary of a cluster, you should be able to have an algorithm that does not use the idea of an existing cluster, so to speak. That is, that can directly deduce these people were in the same place, so to speak, without saying there was a cluster in that place. But maybe the intermediary of thinking about it in terms of clusters makes sense.
I mean, I wonder how you can do that. I mean, if there's really no one, let's say there's a room that you infect and you leave the room, then somebody else go in the room later, then there's really no way.
Well, it's the
right?
same thing as with context of, it's like word to vec or something. I mean, it's like if you can see that there were a bunch of people, if you then come into contact with the same people, you leave the room and there's other people that you come into contact with nearby, then there's a good chance, right? So you can deduce in the same kind of contextual way that you can deduce things, in you get the point. I mean, it's a contextual type thing.
I guess I could have things like that, yeah.
Right. I mean, and so the question is, what's the formalism for dealing with that doesn't require you to go through the idea of blump, there's an actual cluster? How does that work? I mean, how would one get? Well, here, let's take a look at some of the comments on the live stream, then we'll come back to this. Okay, so let's see, from Brian, instead of using passive BLE environment, have all phones use BLE to perform Diffie-Hellman key exchange of ephemeral keys. Yes, I think the typical idea here is that pair-to-pair phones can do that, but they can't exchange. If you've got, your random potted plant with its BLE connected watering device or something, you can't get the algorithm onto that, potted plant that has that does the Diffie-Hellman key exchange. The only place you can do that is a phone that has an app installed. Yeah, so I agree that that's the key exchange is what one wants to be able to do in from phone to phone with apps installed. Okay, let's see. A conjecture that if you have an adjacency matrix of who was closer than epsilon, say BLE range, then you can reconstruct the positions of the individual nodes up to some small error. Marco says he has an algorithm that does that, i.e., if I know for each pair of points whether they're in the same spot, I can reconstruct where they are and were. Okay, so that's what we were trying to do here. So if Marco has an algorithm to do that, then that's great. Okay, let's see. Comment from Joe about access points that triangulate to give you location. Yes, but that requires you have the whole beacon structure set up. And we're kind of, one of our axioms here is don't change the infrastructure. The only thing you can change is apps on phones. Let's see. Some people already record their GPS trace through Google, like with Waze or something, all the time. The app could just ask permission to use it. That's interesting. I assume that's the low precision GPS, but it doesn't really matter. I mean, the app is going to have to ask permission to use GPS anyway on a phone, and it could be recording directly from the phone rather than from an existing, pre-existing trace. Okay, let's see. There's a link here to a paper. Let's see if we can bring that up. Wow, okay. It's got complicated words in the title. Well, it looks like it has some relevant things in here. Not sure. Maybe somebody else could take a look at this. Oh, at least that yeah. Maybe somebody else could take a look. I can't process that quickly enough. Okay, so Holzbrow Frau is asking, what will you gain by tracking across multiple levels? The point here is to deal with the fact that you don't necessarily have to have been, if a person is infected, you can be infected in more ways than just having been in the same place at the same time as that person. Because, for example, aerosolized virus could have been left by that person for some number of minutes after they walked by, or, although I have to say, in any open environment, it seems much less likely. Or, they could have touched something that you then touch. There's the decay time for that appears to be very long, although I don't actually know if there's really evidence of actual people who've theoretically the virus lives on surfaces for days in some cases, but I don't know if there's evidence that anybody's actually been infected in that way.
Have there been any studies on the actual most common transmission vectors for this particular virus?
I think the general belief is it's aerosolized droplets, but I'm not sure.
To be shifting toward that. I mean, at least from the recommendation, at first it was like touch. Then it was like, oh, actually it's droplets. And now it's like, oh, maybe it's aerosolized droplets.
Yeah, but remember droplets, I mean, the main issue is these fomite things that can form on surfaces that sort of keep the virus alive in a sense on a surface for a long period of time. I mean, like on some surfaces up to, a week and things like that. But I don't know, I think it's a yeah. It seems unclear. I think that clearly there is already a lot of useful information to be got by just having this instantaneous, where you're in the same place and same time as somebody who is subsequently shows up to be infected. But it would be nice to be able to at least have the option to allow some delay time.
I suspect I saw a presentation by a New York doctor, and so he is dealing with patients, like they have a big hospital in New York, can't remember which one, where they sort of dropped all the elective surgery and elective procedures, and they only deal with corona. But he said the only case where they use a face mask, where they believe in this droplet theory, is when they intubate someone, when they're trying to make
I think this was honestly, I think this was a weird kind of don't have everybody walk around the country wearing masks idea, because I think that it just seems, also from the epidemiological data on some Asian countries and so on, it just seems to me inconceivable. But I think this is not the problem we're trying to solve here.
No, I'm sorry, I meant face shields, okay? And they had sort of this N95 high-grade face masks. But the other thing was touching, so it was like preventing you from touching your face with your hands.
Yeah, sure. That's one of the effects of a mask, is that you don't end up touching, things that end up in mucous membranes and so on.
Right.
But I think that but look, the basic
it's operating in that environment every day. So
yeah, right. So
it's just
the problem for us here is the algorithmic problem of, one approach is pure instantaneous phone interactions. There seem to be some protocols that people are proposing for dealing with that. The question that I wanted to try to understand is, can one do any better than that? Can one deal with things where there is delayed transmission, or is that hopeless? And I think this is, and how important that is unclear to me, as I think it is unclear to everybody else. The question of whether, how long, there was a claim that aerosolized droplets can hang around for 3 hours, which seems implausible to me, but I don't know. It depends on updrafts in the air and so on, because they do fall eventually. But
they have falling speeds in the order of nanometers per second.
Is that right?
Yeah,
they're that small?
In motion.
But so the size of the droplets is around what, 2 microns or something?
No, it's substantially smaller after a while because they evaporate quickly.
But so like the virus is like 100 nanometers, isn't it?
Yeah.
But so are you saying that the droplets are just virus after a while?
Many of them are just viruses, yes. And this is the one thing that's not quite known yet, how long the virus can survive in this mode when most of the water has been evaporated.
So you're saying if I use Stokes's law or something to determine the drag, so to speak, on you're saying that an individual virus dropped in the air will fall unbelievably slowly.
Correct, because of it's totally dominated by the Brownian motion part rather than by the gravitational part.
Oh, really?
Yeah.
Oh, I see.
It's kind of the
hang around for
5 micrometer order that that really come out when you speak or cough in the worst case, they fall within seconds.
Because they're a couple of microns, right? That's the typical.
Correct.
Right. Okay. So then,
so what does this translate into? Sort of, lingering time.
Well, so Michael is saying
dominated by air movement.
Right. So if it's Brownian motion, that means it's just diffusion.
Yeah.
Right. So it means it's square root of t distance.
But practically, we don't have any environment where this is the case. It's always practically dominated by convection.
Right. Right. Which means that
humidity, you mean, in air? Or?
No. Actual air currents. Air currents.
Oh, okay.
So I mean, and presumably, I don't know whether in indoor spaces. I mean, so does Komogorov's law apply to give you the spectrum of?
I mean, by the way, guys, this is just what they call airborne, right? When in biology, medicine, that's what they consider an airborne, is when that's the way that it's spreading. But this doesn't have the epidemiology of airborne, but that's what they mean by airborne.
That it is purely Brownian.
That effectively its lingering time in the air is large enough that it's where you in the same place. It's not you don't have to be object mediated or anything like that. If they're saying it's airborne, they mean that the areas themselves that have been heavily trafficked in by infected people are effectively a source of infection themselves. But this doesn't seem to have that epidemiology.
Right, unless the air currents get rid of it. I mean, how fast do air currents? Is there an easy way to figure out the turnover time for air currents in a particular space? That is, what will be the and that's why I'm asking, like what is, in fully developed turbulence, you would expect some, eddy size distribution, which would give you information on how, what the mixing time is and so on. Is that must be, well, okay, different physics problem.
I just want to mention one other thing about the levels. We're going to care about levels even before you get to the issue of trying to track space as opposed to contacts, because some of these people are confirmed infected and other people are only 2 ply away in the forward light cone of someone who's infected, or a place where lots of people were infected. So there's going to be different probabilities attached to all these things. You're going to need to know how close you are to any of these things. It's not just going to be the whole forward light cone of everyone touched, I don't think.
I see. So you're making a different claim there. You're saying that another risk is there is this person who was in proximity of somebody who is known to be infected, and you were in the proximity
you're not trying to do forward light cone tracing, right? So if I'm infected and I'm in the vicinity of someone, and he's in the vicinity of someone else later, and he's in the vicinity of someone else later, but it's all on a forward light cone, that is a potential chain of transmission.
Yeah, but one issue there is the virus. When the virus first lands, it doesn't infect you, and you're not infectious until for several days later.
Right. There's an incubation time. You need to have some kind of
that's complicated.
Delay in how far exactly. This is one of the things when people first fitted some of the differential equation models they know are wrong to the Wuhan data. They got a infected population size for the best fit of around 100,000 people, even though there's 11 million people in the city. And that's probably because in the few generations that it had a chance to go through incubation times, it hadn't actually spidered out to hit the web with everybody in the city yet.
Right.
The size of the whole contacted subgraph was only about 1% of the city at that point in time.
Okay, let's concentrate. I mean, we're trying to solve here primarily an algorithmic problem. So I mean, just as a practical matter, the way that I think there is, the useful thing that we could potentially achieve is there a way to uptick the pure, Bluetooth key exchange instantaneous contact model for determining, infection risk? And let's see, let's look at a few other suggestions here. Okay, so hold on.
Can I ask one question about your objection to spatial graph communities? I didn't quite understand earlier. Can
I don't think I had an objection to that. I think we just moved on to a different topic. I think that was a perfectly, I mean, that is part of what I think, I mean, that's a version of what Etienne was saying about clusters, but it might be a more flexible one.
Right. But my understanding was what Etienne was saying about clusters assumes that those are clusters in space, right? In some kind of spatial graph.
The point is, if you let them be in space-time graph, you avoid the problem of the cluster was there and then it diffused. It's still a cluster in the space-time graph.
Exactly. So what I was trying to propose was the notion, extending the notion of a graph community so that it's time extended, as Jason said, so that you have, if you have three people and they happen to be in the same place, and then one of them leaves, so you're left with two people, and then a fourth person joins at some time later. You can treat those as being a four entity graph community in the extended space-time picture.
Okay, but normally graph communities don't care about. Okay, so the issue is you're dealing with graphs that have some kind of partially ordered set character to them as well, right? Because
that's what I was trying to say about the optimization problem, right? So instead of just maximizing the number of internal edges, you're also trying to minimize time differences between those edges.
I see. So in other words, what you might have, so in a normal graph community problem, I mean, if I just take a random graph of 200, 400 or something like this, and I just say, give me the communities in here, the standard computation, that is based on higher connectivity within this graph, right? Those are the regions of higher connectivity. What you're saying is that we want to
in addition to maximizing connection density, you also want to determine, is there some time t that minimizes the difference between a timestamp in an edge and t for that cluster.
I understand. So what you're saying is there's a distance measure between these nodes. There's two distances you care about. The number of the graph distance that is going from node 1 to node 2 to node 3. That's one issue. But isn't it just weighted edges here? Don't you just give the edges weights that are the time difference?
You just have a weight which is probability that you infect another person. And
No, because this is a time. Because the whole point is that this is a directed. Okay, so first question is, are there directed? Am I wrong here?
The problem is it's a multi-weight because there can be multiple intersections between two agents. So it's not enough just to have a single timestamp for each edge.
I understand, but each multi-edge can have. There's a timestamp on each multi-edge.
Right, but then you want to do the optimization over the whole collection of multi-edges.
Right, so you've got multiple edges between two possible nodes, and you have to wait across all of them while also respecting the partial order of not even have the edge be there.
But doesn't it just
exactly?
Doesn't that just, if you look at those timestamps between the pair, can't you just compute a scalar value from that says this is how important it was, how close they were in time?
Sure, but you get to group in the graph algorithm. You get to choose every possible subcommunity to draw these boxes around, and every number of the boxes to draw, right, in order to try to minimize an overall weight, right? And the point is that weight then has to say there's no edge between these at all if it's the wrong direction in time, right? So it has to be forward in time, and then for the ones forward in time, you want to weight the near connections heavier than the far connections.
Right. Yeah, you can't convert to a single scalar because you effectively need all of the incidences in order to do the optimization problem of determining the community.
Well,
you're asking, does there exist a timestamp that minimizes this across all of the multi-edges?
And that timestamp will be the timestamp at which those people were nearby, so to speak.
Right. So yeah, I think what's going to happen is those communities will end up being reasonably good proxies for spaces.
Well, to be clear though, I mean, yes, if you want it to be a single timestamp, you want a purely space-like surface, but you also could have these things could have extended space-time that you don't have to be oriented directly along the time dimension, right?
So then the next question is, what is the norm that we care about? That is, if we knew this person was in the same place as this other person with a delay of delta t, right? What value of delta t would we consider it worth alerting people about? Or is it the case that we can, that there's I've seen these curves for sort of the lifespan of viruses on surfaces and things like that I think are exponential, right? So we might say there's a certain, because obviously one of the practical issues with any scheme like this is if everybody's getting alerts all the time and, then everybody's going to be back being quarantined all the time. Right, it's not going to be useful. What one has to do is get, the right level of alerting, and so my question would be, assume we could choose the time delay, that would still generate an alert. What would we want to do with that? Would we want to say that each person gets a certain weight for whether they should be alerted, and that weight might decay exponentially with time? And if, for example, there were two people both infected who were both in, that person encountered, how would we want to combine those different weightings? Does that make sense? I mean, so because one thing is, if they were in that same space but 2 hours later, it's much less significant than if they were in that same space 5 minutes later. How do we deal with that? And if there are two different exposures, so to speak, for that person, in other words, somebody is in the same space an hour later, two different the same spaces an hour later, how does that compare in their, in whether they should be alerted with being in, for example, the same space half an hour later? Does that make sense?
I think it does make sense. I think it's going to be hard to decide that a priori, but if you have things like survival times, you can definitely use it to inform your delta T kind of clustering. You also just want the cluster analysis itself to tell you something, though, to tell you, this is the tracing of infection that
right.
that actually explains the outbreak trace.
Right. I mean, retrospectively, one can do that study, and I mean, the best trace that exists right now is that I know of is the Singapore data, but that data is, that data is all done retrospectively, I believe. That is, somebody got sick, and the question is, how did they get sick? But that data, the graphs look somewhat like this. I mean, people are asking about simulations. I mean, if you want to, the person who's done the most simulations here, probably that are relevant, is probably Christopher's simulations, which we could probably bring up. I don't know, Christopher, I think you've got some new ones as well, don't you?
Not particularly.
Okay. I mean, this is simulations. The problem with these simulations is, the main takeaway from these simulations is that the details of the network really matter. I think, is that a fair?
Yeah. I mean, there are a bunch of, the details of the network matter.
Right. So let's see. Let me just comment on a few other things from the live stream. So Loco Padre, how about each phone stores its location for some time and reads after each day risk from a server based on the locations that it was at? Right. Yeah, right. I mean, I think the problem of, I think that is not so difficult. Knowing, so in other words, if you have a heat map of these are the places that there was that, unfortunately, okay, on any given day, we don't know anything because people are not going to show up testing positive for quite a number of days. It's a week earlier or a few days earlier, they were in this place and somebody might have gotten infected from them. But it's not like they immediately know that they were, that they're going to test positive. Let's see. Yes, okay. Yeah, so right. Yeah, I mean, a comment here from Sol, I guess, is that it would also be useful, and this is another practical thing for making these apps. If people gave other information, if people were prepared to give other information, like I went out but I was wearing a mask, that would probably change a bunch of probabilities, and it would allow fewer false positives and so on to be generated. But I think the problem is, look, as a long-time doer of personal analytics, my principle of personal analytics, storing God knows how many data points about myself all the time, is that the only stuff I do is stuff that takes no effort to do. I think as soon as there's effort involved, people will tend not to do it. Okay, let me see. Yeah, comments from Sander here about tiny particles and people walking around will mix everything because they have much higher velocity than the velocity of the particles themselves, and air conditioning will mix things even more. Right. Let's see.
I do want to mention one thing since we were talking about alternative sensors. The accelerometer, or the fusion of accelerometer and gyroscope, would be a very accurate way to determine if the phone and conversely, and the person too is in motion relative to the static environment around them or relative to the air around them.
Yes.
And in addition, also, I know that at least for iOS that they have like a little parameter that you can check.
Right. Yeah. You just ask, am I walking or not?
Yeah, exactly. Well, I think it's like walking, driving, and a few others.
I see. Okay.
So that handles stuff like yeah. Go on.
People breathe, and there are air jets that transmit, and it's one more than just walking. So you can just walk by and you're breathing the jet.
Yeah, I understand, but it still gives further information. Like if somebody is driving, I mean,
they're presumably in a car that's contained enough it's separated from someone who Bluetooth's next to them.
Unless they're on a bus.
Sure.
And I doubt that the accelerometer can tell the difference between a car and a bus.
Yeah, but if you're on a bus, there are lots of BLE transmitters around you. Yeah.
You can tell from
right. Okay. Fair enough. Fair enough. So I mean, so you can deduce: are you in a separated car? I mean, look. In the end, you know, if one really wants to do this properly, there's a bunch of kind of machine learning style stuff, very similar to what one has to do for any of these fitness tracking things. Are you walking upstairs? Are you doing this? Are you doing that? These are all essentially classifier problems of, you can identify certain kinds of things like being on your own in a car, which I'm sure you can test by looking, as you say, at whether there is a fleet of BLE stuff going with you or not.
Couldn't the camera on your phone identify if you are wearing a mask or not?
What's that?
The camera on your phone identifies.
Yes, so long as you're prepared to switch the camera on, which I think again is too much to ask.
Or you can infer muffling.
If you're using a Face ID, you could do it anyway. So because you're using the camera at that point.
Oh, I bet that's an interesting point. Actually, I bet the Face ID doesn't work if you're wearing a mask. I mean, I bet that the I could try it on my phone here.
I've done it. It doesn't work.
I think there's.
So then it would ask you, are you wearing a mask or something like that or whatever?
Right, but that requires again can an app get access to the Face ID stuff?
No.
Okay, so that violates the no infrastructure change idea. But it's an interesting point that the Face ID you're sure that an app can't validate. Like if an app wants you, it's only
an app can bring up the dialogue, so to speak, where you can validate yourself using Face ID.
I see.
If the point is that you want to check to see if the person is wearing the mask, can't you just prompt them in the app that we already have to take a photo?
Yes, but I mean, that's a compliance thing which people are not going to go for. I mean, the only way that look, it's only zero effort stuff, like when you open your phone, because if you're wearing a mask, so that will be an issue for people. They're wearing a mask, the Face ID won't work. Presumably you could retrain the Face ID to work with a mask, I assume. Maybe it doesn't. Maybe it's using, mouth key points and it just won't see those. That would be an interesting question to answer. But I mean, that would be the time at which, if the Face ID were to, store a variable that says, is the person wearing a mask, and the app could access it, then you would be in good shape. But absent, that feature, which, would require an OS change, I don't think one can get that. I mean, if one thought that was an incredibly useful, OS change, then that's obviously something to propose, but I don't know how useful it really is.
By the way, for your accelerometer nodes, Android also provides an API method to detect the activity.
Okay. So let's see.
I think there's an interesting question here, which is, what is the false positive rate? In the sense that if I get notified, given, I mean, if the R0 of this thing is between 2 and 3, but in the previous, I don't know, 7 days before you get a positive test back, you've run into a couple of thousand other phones. You're talking about there's a 1 in 1,000 chance that you've infected one of those phones, but we're going to notify them all.
Let's understand that set of claims. Okay, so first point is, you're saying we know how many people you will have infected because we know the value of R0, because by definition R0 is the number of people you're going to infect. But on
averaged over all people, obviously.
Right. Okay, so that's a good point, Philip. That I mean, you know, okay, right? That's a right. So so what's your conclusion? That the false positive rate is ridiculously high for such a thing?
Well, I think it depends on, you know, how many phones do you run into? I mean, and this is actually something that I'm actually going to run my Bluetooth logger as I go out on my afternoon walks, because my suspicion is that in the open air, the BLE certainly much more than the kind of the 6 feet or the 8 feet or the 8 meters or whatever the current distances are. I suspect I'm going to rack up a huge number of BLE devices in not very long.
What about with the decibel level? Because the BLE scanner knows the decibel level for the BLE, the signal strength.
It does. I don't. I mean, my logger, I don't. Well, it'd be interesting to see whether I can just export all the day data and do some filtering based on that. I don't know is the answer. But I mean, how many people do you think that you run into? I mean, presumably the purpose of this is post-lockdown.
Absolutely.
When people are out and they actually need to be able to go visit the supermarket or the...
Yeah, right. And they're at a train station where there's just a gazillion people, you know, or some other environment. What's that?
Well, I was just thinking, you know, the events that people want to have, like either the small events or, you know, the large events like in stadiums and everything. Like that's a huge thing that people want to be able to do.
Yeah, what is I mean, so you're saying if there are 10,000 people in BLE range,
right?
Which there might be. I don't know exactly what the BLE range is, but I could imagine that in a stadium you might have as many people as that in BLE range. Then you're saying, then what happens? I mean, you know, right now, I know that, like, you know, Singapore, that's been probably the most active place that I know of doing contact tracing. They routinely, if there's one person on a plane who tested positive, they trace everybody on the plane. So that's a few hundred people. But I mean, well, okay. So the question is, I mean, that calls into question the whole idea of sort of digital contact tracing, because as you say, if there 10,000 people are going to be picked up in the net, you know, that gets fairly crazy, especially if you have it. Go ahead.
If we're worried about high false positive rate, then why not just return a confidence level as well as a binary notification? Because we have enough information to compute that.
What would people do with it? I mean, in other words, the real question is, there's a threshold at which it's worth telling people, you know, you might have been infected, you should quarantine. But that's an expensive thing to ask somebody to do.
Right, right. But my point is that you can give them more information about, because if we're computing some Bayesian causal network or something, then we can tell them, you know, this is your probability of infection is above 20%. We recommend that you quarantine, but people can come to their own conclusions about what different percentage values mean for them.
Oh gosh, yeah, right. I mean, people have a hard enough time with probability, but I agree that coming up with a value would be useful. I mean, ultimately, one would want to calibrate that value to the actual probability that they are infected, but that will be, you know, over time, data would probably show that. I mean,
Yeah, two comments there. I mean, it seems to me one on the decibel level to how close your contacts are. That's one way you can filter this. The other way you can filter this is actually just try to learn from what you see in the data as you're logging it about actual contacts. And you're not going to see an R0 that's the same in the previous uncontained case. When you have all this data and you know exactly who is next or whatever, that's different from the assumptions used in those models. So you're gonna get a truer picture of it.
Well, let's be realistic. I mean, the models, the differential equation based models, sort of assume that everybody is continuously interacting with strangers. Is a sort of well mixed continuous interaction with strangers approach. You know, these network models where you have a fixed network and you're kind of interacting sort of continually with that fixed network, that's a different assumption, probably closer to the situation we're in right now. But the situation post-lockdown is a situation more like the mixing with strangers situation. But I mean, I think we didn't let Philip finish his point about false positives. Where were you going with that point?
Well, I mean, when you get to a level of basically when you're notified that yes, you were in the same place as somebody else, you passed them in the street, you're actually not very likely to be infected. I think especially this whole discussion around super spreaders who may be doing by the majority of the spreading. And so many of the infected people do not in fact pass it on at all.
Right.
I think the Biogen case is illustrative, where basically, 80 people ended up being infected from presumably one initial person. Now, maybe that was because of the fact they spent a lot of time together. So maybe the length of time you are in the same vicinity is actually a critical parameter.
Yes, that's interesting. I mean, look, I've seen this claim.
Also, if some of the people around you are in your contacts, right? So that makes it more possible that you go closer to the person.
Yeah, but I mean, you know, I've seen this claim, which I don't really understand, that the initial, you know, viral load or whatever, the initial amount of virus that, you know, you get affects how seriously you get the disease. And I don't understand that at all, because I sort of thought that it was all about exponential replication of the virus and that it didn't really matter what the initial amount of virus was. But I mean, certainly.
That means how many different molecules you get inhaled.
Yeah, right. I mean, right. But the point is that if you get too few molecules, your immune system can just wipe it out. But the thing that seems surprising is that you get sort of an attenuated version of the disease if you don't get so many molecules. I just didn't understand that biologically.
I mean, that's a bit like what's happening on the epidemic level, right? It's like if we take action, we can kind of reduce the peak. I guess it's something a bit like that happens, is that if the seed is small enough, then the immune system is losing, but it's not losing so much. And so it kind of make a small peak. Whereas if it's big, they get, you know, completely.
No, actually, that might be right. I mean, there might be some nice differential equation model for that, actually, or cellular automaton model for that matter. And we don't have the right people on this thing to who know about immunology. So, but moving, okay. So the issue that Philip is raising is this whole idea is crazy if the false positive rate is ridiculously high, and
I disagree with that. So even a simpler model. So I discard the geography. So I don't care about locations, just people interacting with each other. If I know the probability that one person that I met with for, say, 2 minutes, with some probability can affect me, and then given this network, then later, suppose I'm walking into a crowded space, what's the probability I'm getting infected? And I decide for myself whether that's high or not. So at least I just want to see, in terms of a single probability, what's my probability of getting infected.
Okay, but one of the points that keeps on getting made here is sort of passing somebody on the street is a different story from spending 2 hours with them. That's the sort of meta claim being made here. And, you know, it stands to reason that the probability that, you know, you'll get enough virus particles to exceed your defenses, so to speak, is much higher if you have 2 hours of exposure than if you have, 2 seconds of exposure. And so, that just highlights, I mean, if indeed that's what matters, then these delayed transmission things are kind of irrelevant. And what more is important is just recording, you're in the same place. Then you're going to have, definitively, you'll have time to have the BLE exchange happen, and you'll just see, 10,000 BLE exchanges with this person. And that's the thing that would trigger the notification and so on.
So there are several things that need to model. There are separate things that need to be modeled because we are hypothesizing without actually making concrete proposals. For example, one of them is depending on the time of interaction of me with another person, what's the probability of getting infected. Another one is, suppose one person was in the room and later I came there. So given this period of time, how the probability decreases. Again, that's a separate model, which
absolutely,
we don't know the answer. We need to model it somehow. Just
right. So I think that second thing, I have seen data on, for example, how long the virus lasts, at least on surfaces, and I think it's an exponential. I don't know. Maybe Michael or somebody knows that.
I just looked at the article yesterday. So depending on the material, up to 72 hours.
No, I understand, but what's the distribution?
You're right, Stephen. It is typically exponentially decaying. Yes.
Right, so it has a half-life of whatever it is, 72 hours, but it's an exponential decay.
Correct.
So now the question is, if you are in contact with a person, if you're, as the amount of time for the contact increases, how does the probability of getting infected increase with that time of contact? Is it linear or is it something else?
Yeah, that's something that we don't know, so we need to model it.
Right, but I would think that the first assumption of that, just like I would guess the first assumption of the decay is exponential, I would guess that the first assumption of probability of being infected is roughly linear with the time of, the contact time, I would think. I mean, I can't see a mechanism where it would be, well,
I would think so too.
Okay, so the only way it will be nonlinear is if, for example, I mean, okay, so here's how it might be nonlinear. Let's say that every minute you get 100 virus particles, right? Then you end up after, and let's say it takes 1 million virus particles to overcome your immune system. Then it could be the case that if the contact time was less than such and such an amount, then you just won't get sick. And if it's greater than, although there'll be individual variation of things, maybe it's more like Poisson statistics or something, where you've got these, some number of virus particles, and it's the question of the probability that you get over some threshold. In which case, that would be like one of these, nonlinear dose response type things that's pretty common in medicine. I don't know whether that's we may not have the right set of people here to address that question. But so there's some function which is a probability given, and different people may be, may have some super spreading characteristic versus others, but there's some function as a function of time that is how the probability of getting sick increases with the contact time. First assumption would be that it's linear, but it may not in fact be linear. And I can see a threshold being possible. Michael, what do you think about that? Do you think that's, I mean, and also I can't do.
I have not read anything about this. Could be, but I have not seen any paper with data about this.
It may also get some saturation because whether you was with a person 1 hour or 2 hours doesn't really make difference.
Right. I mean, there's probably hard to get data on this. There would be data if indeed digital contact tracing is done. There will be data on this because it will be known. There's a comment here about trolls marking things.
If you know precisely how one person got from another, so I presume there are some data,
but look, as I say, the best data I think is from Singapore, and that the network is not terribly large because they haven't, to their credit, they haven't had that many cases and things. Look, I would imagine the way this is going to work is if we're all lucky, there'll be a vaccine or there'll be perfect therapies or something, and the whole thing will just go away. But failing that, there will come a time when basically there are a small number of cases, and when a case happens, there'll be a high desire to try. I mean, this false positive rate depends. If there was a month when in a particular city there was only one case, people will really care about whether they were, even if it's only a chance of, it depends on how the public views it. But, let's say there was a chance of 1 in 1,000 that somebody was going to catch it from that one case in the month. They would probably take that very seriously. Whereas it's a little bit of a different thing if the numbers are different. Let's see.
Sorry, can I mention one thing about the because I think this relates to your question earlier about how do you weight a person being in the same place as an infected person after 5 minutes versus being in 2 infected places after 2 hours or something. If we assume that the infection rate is linear with respect to time spent with a person, and if we assume that the survival rate is inverse exponential, then this is just a Green's function. Because if you construct a Bayesian causal network, then effectively Bayes' theorem gives you a way of defining a potential function on that. So you have some mapping from edges onto real numbers, and then if an infected person acts like an impulse, and then the question is, how does that spread out? And then the lateral spread is given by an inverse exponential. And then, every time every minute, say, that 2 people spend together, that acts like another causal interaction. And so that increases the probability.
Right. So what you're saying is that each person is a linear source. Each person at every time is a source of infection. And as that person is no longer present, that you're basically integrating a bunch of delta functions. At every moment in time, the person is generating an impulse input of infection, so to speak.
Right.
And that
Yeah,
decays
it is a Green function, but the dimension of space is not.
No, there's linear. There's a delta input, but then it's got linear. Exponential decay.
Right, but that's a typical kind of Green's function type thing. Is that you've got the right, and I mean,
right, but the neat thing about this model is that not only does it have the exponential decay kind of built in, but it also has this linear thing built in, because if every hypersurface in this, if every slicing through this causal network is separated by 1 minute, then for every minute 2 people spend in the same place, that's like another causal interaction, and so it increases the probability by some linear amount.
Mm-hmm.
I see what you're saying. So what you're saying is you count causal edges where where the time delay is, where time delay gives you this exponential fall off, but every edge is just it just becomes an additive thing, basically. I mean,
exactly. My point is only that the model that we're inching towards just happens to be exactly a discrete Green's function on the Bayesian causal graph.
Yes, cute. All right, let's.
But you need to look at the outcoming edges. So it's which is a parameter here.
Why?
If the graph, if you have few connections from one point to another, then the spread is
no, but in Jonathan's comment, look, there is a saturation type thing. In other words, but by the time you're at the saturation point, you definitely want to get notified, so to speak, because most of the time your probabilities are going to be quite small, and this linear approximation is going to be quite good. And so that says if there are 2 people, both of whom you might have caught it from, you should add their contributions linearly, right? And the only way that, I mean, it's kind of like the sunburn calculation, so to speak. You can say you can be out in the sun. I don't even know how that works, actually, but you can be out in the sun for an hour, but if you break that into 45 minutes, then a gap, then another 45 minutes, you could still be out in the sun for an hour and a half. And it's similar here. And I could imagine some situation where if you get virus particles and you get them at one time, and then how long can it be before you get, in other words, it's not like lead or something where it's just, like heavy metal poisoning, where it's just building up in your body. In other words, you get these viruses, and within a few hours, those viruses will have been gotten rid of somehow, I would assume. So it is not the case that it purely linearly adds across a whole day or something, if I'm making sense, right? I mean, so in other words, you know, and I don't know how. I mean, your full immune system doesn't get to things that quickly, and I don't know how. But maybe the virus particles. I've no idea what happens to virus particles on you know, one would think that the more primitive immune system would do something, would have a mechanism for getting rid of viruses that just sort of land on you know, epithelium, so to speak. But I don't know how that actually works. But in other words, I don't think this linear assumption can work across large timescales.
Right, but by the time your sum over causal edges is high enough that your linearity approximation breaks down, you've probably caught the virus anyway.
Yes,
would be my
indeed.
argument.
Yes, indeed. But I'm saying that if you're summing small numbers, right, there's a question of whether you're saying it adds linearly, right? I'm saying if it's 5 hours apart, it's not obvious that it adds linearly. Right? In other words, if your virus exposure,
right, but during those 5 hours, you would get the exponential decay. It's only if the causal connections are contiguous.
I see what you're saying. I see what you're saying. But no, wait a minute. But you just got, look, you got you got a contact, and then you get another contact. How do you add those contacts? In other words, if you get 5 contacts, is that 5 times the risk of getting 1 contact? And I claim that depends on how far apart those contacts were, and that is an intrinsic biological feature, not to do with the environment.
Fair enough. Fair.
We had a couple of other comments here. So Sandra on a live stream says he just did the math, and ignoring Brownian motion, assuming Stokes drag, it takes 20 days for a 100 nanometer particle to drop 2 meters through the air. And the Knudsen number is 1, so it might never fall to the ground.
Well, that may decay in the meantime. So yeah.
The virus may. I mean, yeah, if all the water evaporated, the virus isn't going to last too long. But the point is that drafts and so on is much more effective.
It seems to be depending on the temperature. Below freezing, he might be able to survive for years, is conjectured.
Yes, I understand. Let's see. Okay, Mia on our live stream is agreeing with me that the initial amount of virus mattering doesn't make sense to her either. But I think Etienne's argument about you know, the two armies are duking it out, and there's at least a it just doesn't make, well, I don't know. It's hard to know. Right. So comment from Rambod here. Why not score the nodes and alarm a certain top percentage of them? Yes, reasonable. Let's see. Somebody noting it's amazing how little factual data we have on all these questions, and yeah, that's some.
People are too busy with something else.
What's that?
People are busy with actually taking care of the virus and studying.
Well, no, but I mean it's some. Okay. Lolly here is saying that something biologists must have studied. I'm not sure what the that is there. Okay, well, anyway, look, I mean, just zooming out to our original objective and see, and I think we probably have to wrap up soon, but you know, as usual, it's a bit more complicated than one might have thought. But okay, original objective is, can we do better than instantaneous? So first comment is, it is worth storing how long if there are instantaneous contacts, it's worth storing how long those instantaneous contacts were. You know, can we do better than purely instantaneous contacts? The answer is, it seems yes, by various methods. It seems that there are two basic practical approaches. One is to use BLE environment information, and the other is to use the graph of instantaneous contacts. Both of these have somewhat complicated privacy, implications. an additional piece is, if when storing environmental information, storing accelerometer information seems worthwhile as well. I guess one question that we might have here is, in terms of the exchange of all this data, is there an issue with how that happens, or is that straightforward? Is blockchain relevant? Does it have to be the case that all of this happens with a single app vendor or not?
So I sent you a notebook with an example using the cloud and the Arc blockchain. It's just a basic idea on
doing
how
what?
To store the data from the cell phone on the cloud, and just an ID related to that in the blockchain. So if you scroll up. All right, so yeah, starting the basic example section. So the idea is that the phone generates all this data that we've been talking about, and a phone can make, any phone can make a HTTP request from an app, right? So we could have something. So we could have something like an API function deployed in our cloud that receives this data. This is just some sample data. And that API function puts the data in the cloud. So that's a simulation of that using Cloud Boot.
Okay.
And then what you store in the blockchain is just the, so if you scroll down, you'll see, I use a real transaction there. So you store in the blockchain a reference to that cloud object. In this case, I created.
But okay, just zooming out for a second. Okay, so the mechanics of storing the thing on the blockchain, I'm sure, can be solved. The question is, what's the need to, the claim is that, is it useful? So one approach is, it's simply a push notification to all phones on the network that says, here's a bunch of dangerous UUIDs you might have seen. Check whether you have any of these. Or more sophisticatedly, use some perceptual hash mechanism to find out if you're close to one of these or whatever else. That seems like the minimal approach. So the question would be, is there a reason to have a public ledger of information or not? Or does the public ledger add nothing to this? Because
the only reason would be for the data not to be tampered with. That's the only reason. You could store it in a regular database and it wouldn't be a problem. Putting it in a blockchain would give us an additional level of security. That's it.
Well, so you're saying that if a person, if a person was going to be a troll, so to speak, they could perfectly well be over time just storing weird stuff in the blockchain, and then then they say, oh, they got sick, and then they push out all the stuff that was in the blockchain. What protection is there against that?
So in this case, the data in the cloud is hashed. That hash is also stored in the blockchain, and you can also compare the timestamps between.
No, I understand that, but if somebody is going to troll, they can be setting up their trolling for a week in advance, and
they're going to declare themselves sick, or are they? It's that this information is going to.
Yeah, I don't actually see the point of doing that. Hey, Philip, you're an expert in weird things like that people do. Why would somebody want to do that? Why would somebody want to? I guess the reason would just be, look, the bad reason is just, oh, you want to panic everybody who is in such and such a place.
No, people play with these things. They just try. Can I do this?
You want to have something where when they actually test positive, there's some kind of code that's given out. We don't store anything, right? Or the apps doesn't store anything unless that code accompanied the actual notification that someone was sick. That way nobody can fake being sick.
Right. Well, so that's a digital signature type problem, I would think, that you can only if you get the right token can you. And I think that's what these protocols have in mind, is that only if you get the right token are you enabled to, because the push notification has to happen through a central server. So, and I mean the central, well, in that model at least, then the central server just won't do it unless you have the appropriate token.
You could do that with central server, or you could do it blockchain enabled, as long as the health authority issuing the token, right, also sends it out, whatever information onto the blockchain. You could have it be distributed then. It wouldn't have to be centralized, but there still has to be some kind of security protocol that unless there's an original verification event from the health authority saying this person is positive, then their UUIDs can't be broadcast to the network as
right. So can somebody think, I mean, in terms of the way the cryptography works, is it obvious how, the health authority has some kind of private key that they use to determine, to set this up? I mean, to be able to...
I mean, in some sense, if you take the view that what happens is that when you get infected, you get this token that's essentially you can view as kind of a one-time username and password that allows you to upload your contacts to a centralized database. And then everybody else only has read-only access to it. And you don't need any fancy anything, really.
No, you have to be able to upload often, because your information may be used by others. You will be in the intermediary between others.
Well, okay, but that's in the model where one is going, yes, in the model where there's intermediaries, that's less clear. So Philip, what about that case? So, I mean, in the case where all you have to do, you show up positive and then you upload your data, that's one situation. But if one wants to have all the intermediaries' data also uploaded, those intermediaries could be spoofing all kinds of things.
And they will be, because that's how people are. I think what's more interesting is whether I can then use that to track somebody else. If I know I've met them once, can I?
Yeah, right. I see what
can I somehow upload something that will allow me to figure out where they are in the future, or where they were between those two times?
Right. So in other words, because you don't necessarily get enabled to know that you were in the same place as them unless there is an infection event that essentially, opens the door to being able to see things.
Yeah, but I get very worried about if I'm uploading constantly, who has access to that data? Can they use it to track my motion?
Nobody knows that you are is you.
No, but that's never good enough. That's never ever good enough. By the time the person spends most of their time at this GPS location, you've already de-anonymized them. I mean, I think that no, but let's explore that for a second. I mean, if you're storing, what happens when people upload their GPS tracks? People just do that to various kinds of navigation providers, right? They just upload GPS tracks.
Yeah, and look at all the problems. I mean, look at the problems the US government's having with Strava. You can find all the US bases around the world because they have high concentrations of people taking exercise.
Right. Mm-hmm. Right. But I mean, but why don't people worry? I mean, I don't know how things like Waze or whatever. I mean, is there any protection, or people just uploading their GPS tracks and hoping for the best?
I think that's what happens unless you're one of the paranoid types who keeps all this stuff turned off.
Right. Okay, fair enough. But I mean, the assertion is being made here. So why isn't it? So people are not worried. They're kind of trusting the central navigation providers to not go and provide that data to the bad guys, so to speak. Is that right? Whereas here, what you're concerned about is more of a peer-to-peer mechanism of people, somebody, your stalking neighbor down the street or something getting the data. Is that the point? I mean, because otherwise the concept of people uploading, I mean, I suppose the other point is that one wants some situation where people are very unworried about this app, because otherwise not enough people will use it. I mean, for whatever reason, like, I don't upload my navigation data to some central server. I keep it myself, but I don't upload it anywhere else. But
you only need around 60% of people opting in to keep R0 very, very small. Like Germany is contemplating about this right now, and current estimations are from questionnaires, 48% of all people would be willing right now immediately to opt in, and we think we have no problem finding the remaining 12.
Opt into what?
That the government stores the location data.
Okay. I wonder what that number would be for the US. That's a very interesting, it's one of those, international country data things. What fraction of the population trusts their government well enough to let the government store location data for them?
This is probably highly dependent on the country.
And probably the time as well.
Yeah.
What's happening. I think pandemics will increase that number considerably.
And Austria is contemplating making it mandatory.
Well, now in Peru last week, the government released an app where you can also track infected people, and it says that they will keep your data during this emergency time. That's what the app says.
It's a government produced app.
Yeah.
Well, it's interesting. I mean, okay. And so that's based on GPS tracking, is that correct?
They asked you to give permissions for GPS and Bluetooth. Only gave GPS.
But so the Bluetooth is just being used to improve the accuracy of GPS tracking?
I'm not sure.
And how is well, okay, so I mean, maybe the thing we are discussing is an American problem, because I don't think that will work in the US. To have, I don't think enough people, maybe I'm wrong, will but is that, I see. So, but how are they going to deal with a false positive rate? What do they do for a train station that has thousands of people going through it?
We buy right now. The idea for Germany is we buy the bullet. They are mandatory, having to be home, get fully paid for 1 week.
For everybody at the train station?
Yeah.
Wow.
That's the current idea.
Okay.
Nobody has a better idea right now to get it under control, as long as we don't, as you said earlier, have a vaccine. Yeah. It's still far cheaper than what we do right now, where everybody is home.
No, that's for sure. But I wonder so the next question is what the network of even distant human contacts is. In other words, how quickly does the whole population in that model, what fraction, and has that been modeled, what fraction of the population ends up being quarantined for what fraction of the time, based on the typical activities that people do?
I looked for this. I don't think anybody, to the best of my knowledge, has currently modeled this.
It's also going to depend on what the actual prevalence is when you come out of quarantine. If you got most of it in the quarantine period, then you're in much better shape than if you've got it everywhere.
Absolutely.
Everywhere, it's going to hit everybody.
See, I think one of the things, and that's what comes out of this network modeling stuff, is that different people, like, in my own rather boring case, right? I don't come into contact, there are these small bursts where I come into contact with large numbers of people, but most of the time I don't come into contact with a large number of people. Whereas there are other people and other occupations where people will be, throughout the day, they'll be coming into contact with zillions and zillions of strangers, basically. And I suspect that there's very high variability in the population to how many people any given person comes into contact with in a given day, and whether it is a repeat set of people, like they're in an office somewhere with the same set of 30 people, or whether it's, they are at some, kiosk selling something or other where, new customers walk up every 2 minutes. And I mean,
right, but that's why we need a feedback system like this, is so that we can see whether or not people in those kind of situations having things like plastic shields and face masks lets them keep carrying on, or causes a problem and requires a new shutdown. Right. That's why we need data as it's happening in real time to tell where the problem areas are.
Right. So you're saying that the population study, that the first step is to get the data from this digital contact tracing. Second thing is to know. Although GPS is not going to be sufficient to answer the question, well, I don't know whether it is, but I mean, I'm just imagining the person who is like, selling stuff at a kiosk, and different people are walking up, and Is GPS enough to know? Gosh, I mean, I don't know.
My point is, before you do actual analytics on the data coming from this thing, it's going to give you way too high a false positive rate, and you're going to have to do a bunch of analytics on the data that comes out of it before you can get the false positive rate down.
I see. So your claim is that the transition looks like, you have the system set up, but the system is basically quarantining almost everybody at the beginning. It's telling almost everybody you might have been coming into contact with this, but over time you claim, of course, the very act of quarantining is going to mess up the data again, because you're going to not. Well, maybe you get.
It's gonna let you isolate actual causes of transmission, right? Because the people who are quarantining are going to stop infecting anybody, and if you don't have a lot of outbreaks at first, right? So it's going to be a feedback system, and it's going to help you hone in on the places where infection is actually happening, as opposed to places where you only fear that it is happening.
Right.
And if you deploy this scheme, sorry. Go on.
Okay, no, I just wanted to add that just recording data in GPS of where you were at, and probably BLE of who you were surrounded with in time will give you enough data to learn more stuff. And probably
for sure, yeah, right. But I mean, it's also
that's enough for an app.
Well, the feedback loop, however, is rather slow because of this business about people. The incubation period is quite long, and the time scale of the incubation period is long on the scale of sort of economic effects of shutdowns and so on.
Right. The other issue is that we don't actually know how much of it is environmental transition as opposed to person at the same time. So we start with some system that only has the phone contact stuff. We're going to see a residual of stuff that you're not going to be able to fit well from just that data, because there is probably some through environment transition going on, and you'll get a handle on that by whether or not you can actually see and explain the outbreaks as they reoccur, or you can't. If you can't, it's because.
But I saw this recent paper from the Oxford group kind of tried to quantify this for the first time, and at least as a rough idea is 10% are environment.
Oh, is that right?
Yeah.
And what aspects of the environment are most significant?
This is not clear yet.
But how did they deduce that?
I think by mostly accounting for the non-environment.
By what? By contact tracing or what?
Yeah, and others, yeah.
I didn't know anybody had done contact tracing well enough to be able to do that.
I mean, that's probably, that might be off by a factor too, but at least it gives right now an order of magnitude.
The place you could get a handle on this, by the way, is if you tried to compare some of the cruise ship outbreaks with something like a Singapore outbreak.
Because
the cruise ship, you've probably got a lot more shared environment transition, especially once people are already in their cabins, right? As opposed to Singapore, where you've probably got the best contact tracing of actual human-human contact. If one or the other is leaving a big residual in what you can explain from either assumption, then the other factor has to be going. That's the place you've got the best data on human-to-human transmission, like a place like Singapore, where they do good contact tracing early, and cruise ships, a place where they quarantine everybody in their cabins relatively quickly, but everybody.
Yeah, but they were still delivering food and so on, so that was environmental transmission, right?
By the way, am I not right in saying that as long as this app is deployed sort of toward just before the lockdown starts being phased out, the high false positive rate isn't really an issue? Right.
I see. Well, so what do you say?
Because if you're forcing people to go back into quarantine when lockdown is only just being phased out anyway, then and as long as you hope that your data improves as the lockdown gradually phases out, you can tolerate a very, very high initial false positive rate and actually have minimal disruption.
Well, sure, that's true. I mean, in other words, it's the soft coming out of lockdown mechanism where it's a little bit weird. I mean, it's a little kind of weird sort of lottery thing. Well, you can probably go to work, except you were told you can't go to work.
Right.
But
it's way less disruptive than deploying it after, in the post-lockdown era.
Oh,
where
sure.
Suddenly you're saying,
yeah, right. No, that's for sure. Okay, let's just look at these comments, and then we probably have to wrap up here. Let's see. Comment here about rotating UUIDs, not so easy to track a person. Yes, for sure, that's true. Let's see, the app registered its own blockchain and decryption key. Okay, this is a protocol for key exchange. Let's see. Okay, this is a suggestion from Carolina with a couple of suggestions about specific protocols here for contact tracing algorithms. I don't know whether those are digital ones or something else. All right. Well, we should probably wrap up here. It sounds like we actually have made decent progress towards an algorithm, but it is not completely clear that it's not the value is not completely clear. Although there's clearly some incremental value relative to the pure instantaneous phone phone contact thing. But it may also be that the practicality is people recording GPS traces and allowing high false positive rates. Okay, anybody got any last comments here before we wrap up?
Did we deal with people who have the antibodies and are now like presumably won't get
that's a whole different thing. I mean, there isn't yet an antibody test, is there? I mean, there could be, and I don't know why there isn't one, but there isn't yet one, so far as I know. I mean,
because that would also go ahead.
Yeah, I mean, for sure, that will be, the fraction of people who've gotten this is presumably still comparatively small, so that the effect from people who have the antibodies is still, not a huge effect. But I agree that that's a, that's another data point. Although that's
maybe someone else has data on that, but I heard it. They started to do random testing in Sweden to establish the dark number, and the factors that come up is between 12 and 15, apparently, compared to what's been tested and admitted.
What do you mean? The factor, the fraction that
so the question is, how many people get sick, but we don't have it in our statistics?
Right, that they're asymptomatic, they don't show up. And so
they might be symptomatic, but there's no test, so we don't know. They don't go to the hospital. Okay,
so you're claiming that number, which is, I think, consistent with some other ones, is you're claiming 1 in 12 to 1 in 15 people.
Yeah, that's what I heard.
Right.
Yeah. But we do account for that in our model because our causal graph supports event horizons, and that's what an immune person is, an event horizon.
You see, to some people, everything with people with certain kinds of hammers, the whole universe.
I know. Yeah.
But that's a yeah. I mean, right. An immune person is a person where the causality of infection, the virus can't go through them, and therefore they represent a causal horizon, aka a black hole.
Right.
The number of asymptomatic one seems to be substantially lower than what people thought. According to some recent study in Munich, it's probably less than 20%. The symptoms were just so little that people did not record them properly.
Wait a minute, but asymptomatic as opposed to small?
Exactly. Once, if you know what you're looking for, it seems at least 80% have some kind of symptoms.
Mm-hmm.
At some point in the life cycle of the disease. That's the other issue there, is that a lot of people are asymptomatic at some point, but that's a time slice.
Seemed to be a very nasty disease. My brother just went through it.
Yeah, well,
so regarding real cases that we don't know how many real cases are, we could potentially do something with our with the genetic data we have in our repository, because there, at least in entomology, there are some methods where they use the amount of mutations in insects to infer the population size.
Yeah, right. No, actually, this person, Trevor Bedford, who has this whole giant project that is based on looking at the tree of evolution of the virus. He was very successful in Washington State in predicting how many infections there actually were based on the mutation rate of the virus and the number of samples that had actually been taken. So yes, I think the problem is that there still aren't that many genetic sequences that have been sampled. I mean, it's.
So have you guys seen any data whatsoever in the US for what the dark number of infections is? I've not.
I think the Sentinel testing in the US that was supposed to happen, I don't know whether it's actually happened.
So I think we have truly dark numbers in the US.
Right.
My only knowledge on that is that some of the stuff about growth rate was clearly signs of increasing visibility as the tests were rolled out. So you can look at the background rate of doubling as being significantly lower than the rate of uptick you were seeing for a while there in the US, and so that was clearly just higher visibility. So as those converge, it's going to look like the virus slowing down, but it really just means that you're actually seeing all of it now.
Yes.
In lots of countries, you saw 24% day-on-day growth rates when you were getting increasing visibility, and then it stabilized around 12% when you actually had constant visibility. That doesn't mean you're seeing all of it, but it means if your visibility is increasing, you're going to see something like a 12% rate. And before that, when you were just rolling out the testing, you would see rates in up to double that.
I see. So your claim is that the decrease in the increase rate could be a consequence of just the fact that testing is not yet saturated, so to speak.
Right. Testing has now reached the point where it's keeping up and growing. When testing was rolling out much faster than the virus was increasing, you were seeing an increasing portion of the cases, right?
Right. And that makes perfect sense.
And so that's one of the reasons why you're seeing the changes in the rates. Obviously, you can also see an actual downtick in the rate when you actually pass the peak, which might be like happening in Italy now. That'll show up as a lower death rate, not just a lower case rate.
Right. Well, we should probably wrap up here. There was one comment on the live stream that Taiwan did a Bluetooth app, apparently. That's I did not know that. I actually have not seen a nice table. Maybe we should curate that of what has actually happened with these digital contact tracing proposals in different countries. And I don't know, I don't know in detail what everybody has done. Yeah. Well, okay. Well, look, thanks everybody. It was an interesting discussion, even though, and I think we kind of need to find out from the folks who are trying to make these apps, if people really care about trying to uptick the algorithm, then we'll figure out how to do it. If it doesn't seem to matter much, then we shouldn't do it. Anyway, interesting discussion. Thanks to folks here live, and thanks to people on our live stream. So, and until the next time.